Hi and welcome to my second video on integration by recognition or inspection. So we're going to do this example here. Now this is actually a little bit trickier than the other two examples I showed you, but it's still quite doable, and it's a really good one to show you how you might do this without the initial derivative question. But realistically I can't see that you'll get many opportunities where you'd have to do a question this hard beyond you've been given the derivative, but it's always really interesting and it's a good way to challenge yourself to see if you can work out what the actual initial function might have been. So I'm looking at this, and when you look at a question like this, you're really trying to spot, why can't I just integrate it straight away? And at the moment I can't integrate it straight away because there's a denominator and a numerator. There's not just one function, there's two things happening here. So as soon as you determine that, you need to think, what's the main thing? And what's the additional thing? So the main thing here is this square root of 1 plus x squared. That's the main thing. So that's the thing that's there that probably predominates the equation, and we've just got this x on top. So there's an interesting result here that will come out of this, but what I'm going to do is I'm going to explore. I'm going to explore, well, this denominator, what happens if I just derive that? Do I get something that looks like this? So let's say we started with y equals the denominator, and it's a really good way to start if you've got a fraction-based question. Start with the denominator. It's almost always the case that that will be the thing you need to derive. Sometimes it might be a log function, because of course when you derive log of the denominator, you get 1 over that thing. So it could be that as well. I'm going to start with this though. So if I derive this, what I'm going to do first, I'm going to write it in power form, x squared to the power of a half. And then I'm going to derive it, and then I'm going to derive it, which gives me dy dx is equal to 1 half 1 plus x squared to the power of negative a half times the derivative of the inside function, which is 1 plus x squared. And hopefully you can see that this is equal to 1 half times 2x 1 plus x squared to the power of negative a half. Now the 2's obviously cancel out there, leaving me x, but it's x and this has got a negative power here. So what I'm going to do is I'm going to change this. I'll move this across, ruin my board, there we go. It's x over 1 plus x squared to the power of a half, which of course is equal to x over the square root of 1 plus x squared. So that's saying that if I start with this function and derive it, I get 10 to that. Now this has been quite nice because that's exactly this. So as soon as I get to here, that's exactly this, I'm happy. I'm actually happy if this has got any multiplier at the front as well. So that's probably not the best choice of colours, pretty close to yellow, but if it's got an A at the front, so let's say it ended up being 7x or something like that, then still I can get this to work. If the function itself has changed at all, then the link's not going to be there. So if this was x squared on top, we'd have a problem because the link wouldn't be there. But this has actually worked out quite nicely for me. So I finished it off nice and neatly. We'll go to that A there. We go back to here and go, well, I know that this is dy dx. When I derive that function, I get this. So when I integrate the result of that, I go back to what I started with. So this will be equal to 1 plus x squared to the power of a half plus c. So there you have it, a slightly harder question where you've got to try and guess what the initial function might have been. But realistically, once you practice a few of these, you'll see what they're generally going to be. And it's a good little skill to have, even though any question, simple familiar, complex familiar, and probably complex and unfamiliar range will provide you with the derivative first. Happy days.